Hi, welcome to this session where we're going to be introducing you to what's big data. Uh, we'll be talking about this with a small example, and then I'll introduce you to Hadoop. So, big data is typically a broad term that's associated with data sets that are so large and complex in nature that the traditional systems today are incapable to store the data and process it. The reason for this is quite obvious because the world has been generating huge amount of data in the past few years, and the storage levels have crossed the threshold. So any enterprise is running through a risk of running out of the storage space, and I think that's where we are heading towards the problem of big data. Let me just give you a small example on this. Maybe about, say, a couple of decades or maybe about 15 years ago, we were talking about computers that were having few kilobytes of RAM and few megabytes of storage. 100 MB hard drive with about, say, 256 KB of RAM, and that was quite a decent amount of configuration, I would say. Now, today we talk about 1 terabyte of storage or more, and few gigabytes of RAM, like 8 GB RAM or maybe 16 GB of RAM. So that's where we stand today, right? If you look at it, there's not much of change here in terms of the rows in this table, but what you see is that the change in terms of the value of data has always been exponential, right? So this is where we were to probably this is where we are now. That's where I think we are leading towards the problem of big data, right? And I'm sure very soon, within about a few months after we purchase a computer, we run short of even 1 terabyte of storage. So we buy these external hard drives to store our additional data. Apparently, what happens is that we just end up storing it. We don't really process that data. We don't really get any meaningful information out of it. As the size of the data grows, uh, the amount of information that actually makes sense would really come down in terms of the percentage. While we talk about terabytes of storage being a very common thing today, uh, these are some of the words I think that are bothering the enterprise, because the entire world today has generated close to about 4 zettabytes of data. That's the amount of data that the digital world has today, which is a massive amount, I would say, at least with respect to the value of the data. So that's where it's more evident that big data is almost everywhere today. One or the other day, it's inevitable that any industry would be looking out for solutions to handle their big data problems. And in today's world, we talk about data in different forms. It's just not the structured RDBMS kind of data anymore, right? If I'm talking about Facebook, for example, uh, the type of data that we upload as users on Facebook is in the form of images, in the form of videos, and in the form of comments. There's a lot mostly unstructured in nature. They do not really have a fixed schema or a structure, right? So big data essentially is associated with three attributes. One is the variety, another one is the volume, and the velocity. Variety itself means in the social media, any site like Facebook today, we have data in wide variety, as I mentioned. Could be images, or could be videos, or could be text, anything, right? So it's beyond the control of the RDBMS. So RDBMS probably is not the right fit to handle this data. That's the variety aspect. The volume is growing. Once the data enters into the system, it never gets deleted. So the stack, grows over time, and the growth has been exponential, as we've seen here, just here, you know. Um, and the velocity typically refers to the speed at which the data is coming in. If you see here, Facebook is generating about 500 plus terabytes of data per day, uh, which means it's huge, right? So there are close to about 600,000 status updates every minute that happens in Facebook, and obviously ends up generating about close to 500 plus terabytes of data per day. How do they handle it? There are two problems in this particular situation. One is that how do they store so much of data, and how do they make sense out of that data, right? So one side of the problem is about storage, and another side of the problem is about processing. But then Facebook has definitely been successfully handling this over the past few years. Uh, they have a 300 petabyte warehouse which can easily process so much of data per day, right? And all that system is built on top of systems like Hadoop, right? So that's where Hadoop is bringing in value. We kind of saw that there are two problems that we refer to. One was the storage aspect, and the other one was the processing. So the next slide talks about what is Hadoop. It's to fix the problem both ways. One side of that, to store the data successfully in whatever is the size, in terabytes, petabytes, yeah. And then once you have stored it successfully, then and in a very simplified way, and once you've simplified the storage, process it easily. So how does Hadoop handle this? Is because Hadoop gives you a framework that enables you to distribute your data and enable a distributed storage. And once you have stored it in a distributed fashion, to simplify distributed storage, you don't just store 1 terabyte of file in one computer. You spread it across maybe about, with say, 20 or 25 different computers, which means you have broken that massive data into small chunks and stored it on all these 20, 25 odd computers. So once you have successfully distributed this big file into small chunks, then you do a Mapreduce, which means you write a program, move it to the place where this chunk of data resides, and then process it locally, which means now it's, instead of one computer, there are about 25 computers processing this entire data, which can enable parallelism and then give out the information that you're looking for. So that's exactly what Hadoop does, distributed storage, and the storage can happen on commodity hardware, which is cheap hardware. It need not be the enterprise hardware, unlike your RDBMS systems, and it also enables parallel processing. So that's why it's robust. It's very popular today, and that's how Hadoop is trying to simplify the problem of big data. So let's look at the landscape of the entire Hadoop ecosystem. The core of this is the storage, which is the HDFS, and then the processing is taken care by the Mapreduce framework. Apart from that, there are many other tools if you see here, right? So this is the entire ecosystem today. It's just gone beyond the storage and Mapreduce. Now there are tools like Hive, Pig, Uzi, Mahout are, that are also associated with your Hadoop systems. And then you have this coordination services like Zookeeper, Flume, and Scoop. Flume and Scoop are typically associated with transferring data or bringing in data into Hadoop. Scoop refers to bringing data from your RDBMS systems like say MySQL. Scoop itself means SQL to Hadoop. And then now that the ecosystem is getting matured, we need monitoring systems in place. So Ambari definitely helps with managing the clusters. And then there is also something called a NoSQL movement, which is kind of getting very popular these days. Again, this life beyond SQL, and that's what HBase also is a part of. So this is the entire Hadoop ecosystem, and